Hey guys, so we're doing our last section in Unit 3 here. So we're going to deal with the inverse trig functions, okay? Now, if you remember from secondary 3, and we talked about our unit circle and everything, when we went backwards doing that inverse, we had some issues that we needed to confront. Because if we switch x and y, what happens is our sine and our cosine, right? Well, if we flip it, it's no longer a function. So we have to restrict what we're doing so that way we can still deal with the function. So this right here is just a review, okay? One of the things I want to point out here is arc sine x is the same thing as us saying the inverse, okay? So when you see the -1, which is usually our inverse sign, right? Arc sine and all that stays the same. So what we wanted to remind you is we had to restrict the domain so that way our graph is still a function, or a function is still a function, right? So down here, and as you can see, I put the -1 there because they equal. Right here, I'm just graphing the inverse functions, and you guys can use your unit circle to remember what that was. So if you look at where sine is -1, well, it's -1 at -pi². Where is sine 0? Well, sine 0 is at 0. And where is sine 1? It's at pi/2. Now, I know this looks linear, but you know it's not that smooth. Okay. Now, we don't have to go any further because we are restricting. If you remember correctly from the unit circle, right? So if I draw a unit circle here, remember when we used to go backwards, you should have been covering up for sine the left side, because our range is only going from -pi/2 to pi/2, right? Okay, where cosine, we actually cover up the bottom and we go from 0 to pi. So if we look at this at -1, where is cosine? -1, well, it's at pi. Where is cosine 0? Well, at pi/2. And where is cosine 1? Well, that's at 0. And again, we have this curve. Okay, so as you can see, our range is restricted from 0 to pi. When it comes to our tangent, if you remember, at pi and -pi, at pi/2 and -pi/2, we have a asymptote there, right? So if you remember, when we do our range restrictions, what happens is that it's going to get closer and closer. So of course at -1, we are at pi/4, right? At 0, we're at 0, and at 1, we're pi/4. And what happens is it gets closer and closer to pi/2 and -pi/2. But remember, if we went forwards, it would be undefined. So that's why it's our asymptotes. Okay, now this is just a reminder. You guys will not have to remember this right here. Now, it does have us practice some of these without a calculator and things like that. So this is kind of where they have a drawing up here of what we did with our unit circle. When those of you, at least if I taught you to cover it up and then find it. Cover it up where it is to go backwards, okay? So that's what I want you to do right now. I kind of want you to think of this as a unit circle. Fill it out where you need to, because you should have that memorized by now. And then we can go from there. So we are doing, we're actually, in this case, for these three, we're going forward, right? So if we think of sine -pi/6, well, -pi/6 means we're actually going clockwise, not counterclockwise. So we're down here, right? And if I make my triangle here, we have our 2, -1, and then the square root of 3. All right, so our value is, of course, sine is opposite over hypotenuse, which is -1/2. Of course, if you made your full unit circle right now, you could go to that -π/6, right? And which is 11π/6. And that's where we do it right here, right? We go to that 11π/6. And we get the value of -1/2 when we have our unit circle filled out, okay? Now, let's do B really quickly since it's right there. Now, on our whole unit circle, because we're not going backwards, we're dealing with the whole unit circle, we can find 7π/6, which of course is right over here. And when we draw it out, we look and we say, okay, the sine value there is -1/2. They're all -1/2. So what happens when we do the inverse? Well, this is where we need to be careful, okay? Because we are going to cover up the left side of our unit circle, all right? And if we try to find -1/2 for sine, we see that we're down here, okay? Now, if we look at a normal unit circle, we would say that this is 11π/6. But can you remember what happened last year? To get to 11π/6, I must cross over that territory we cannot cross over. So to get to this, I actually have to go backwards. And when you go backwards, you do the negative of it. So the only answer to the inverse of it, inverse sine of -1/2 is -π/6. It is not 7π/6 because we're in no man's territory, I guess, according to sine. And we can't do 11π/6 because we have to travel into there. So we must only go to the left. Excuse me, guys. All right, so what happens with tangent? Well, the good thing is tangent is the same thing as sine, where we cover up that left side. Okay, so when we look at our unit circle and we say arc tangent of 1, so where is tangent 1 on the left side here? All right, well, let's think about this. Sorry. So we get π/4, right? It's 1 over here. Now we have a trick thing with that too, because don't we have, no we don't, no we don't, because remember when I look at this one over here, this one's not 1, it's -1. So our only value right here is π/4. All right, let's think cosine. Cosine, I said, cover up the bottom. We're gonna look for cosine being -1. Well, where's cosine -1 on your unit circle? It's at pi. All right, inverse sine. Again, they're trying to interchange them, so you get used to it, that means the same thing. Remember sine? We cover up that left side, and we're looking for square root of 3/2, a positive square root of 3/2, which of course, if we go there, it's at pi/3. You have to have your unit circle memorized, guys, or at least write it down so you have it all there. 2, cover up. Do we have 2 anywhere on this unit circle? No, we don't. So the answer does not exist. Awesome, guys. Okay, here we're going to use our calculator. So if you can't remember, because we always have to remember how to use our calculator here, make sure you're in radians. And inverse sine, so mine's in blue. So I'm going to go second, inverse sine, 0.3, and I get my value. Don't forget, we're going to the third decimal place. So 0.305. Okay. Inverse tangent of -5/2, we get -1.190. Good job. Sorry, guys. All right, what happens here? Well, first of all, I want to show you something. Pi/3, or square root of 3/2. Well, these two cancel. They cancel because our inverse is on the inside. When the inverse is on the inside, we can cancel and our value is 3. Now, what we have to be careful is, hold on guys, I'm going to pause. There's an announcement. Craziness, sorry. Okay, when the arc or the inverse is on the outside, we have to make sure the condition still exists. And what I mean by condition is we have to look, hey, where do we have to cover things up? So arc, cosine, cosine pi/3. Well, if I do arc, I have to cover it up down here. Does pi/3 still exist in our open spot and we don't run into trouble? Well, pi/3 is up here. So yes, we are okay. So our answer is pi/3. Now, what did I mean by that? How do you know? Well, let's look at this. Arc sine, sine. The inverse is on the outside. So I need to make sure that I'm in play. All right, let's look at this. So arc sine means that I'm going to cover up the left side. But if I look at pi/6, it's over here. And with my arc, I run back into it, but I run into the stuff that I can't have. So what's going to happen here is I'm not going to put 11 pi/6, but I'm going to go backwards, clockwise, to see what I can do with negative. And 11 pi/6, but going from clockwise is negative pi/6. Craziness, huh, guys? Okay, let's solve for x in this case. Well, inverse operations, right? How do we get rid of an arc sine? Well, just take the sine of it. And whatever we do to one side, we do to the other. So those would cancel, right? Remember, arc on the inside just cancels. We get x squared minus 3 equals, well, what is sine pi/2? Okay, pi/2 sine is 1. X squared equals 4. Take the square root of both sides. We get x equals, don't forget, when you take a square root of solving, how many answers do you get? 2, plus or minus 2. All right. Sketch a right triangle and evaluate without a calculator. So x equals, now, why did they do that? Well, because 2 and square root of 5 are not really on our, or they're not our nice numbers on our unit circle. So what we're going to do is we're going to draw this out and then find tan x. Okay, well, first of all, arc cosine, we don't do on the bottom. So I'm just going to make it this way since it's positive, because over here cosine is negative. Okay, now cosine is what over what? Cosine is adjacent over hypotenuse, right? Well, that's great. For tangent, though, we need opposites still, right? So how can we find that third side, guys? We can do the Pythagorean Theorem, right? So we have that a squared plus 4, which is 2 squared, by the way, equals, and then squaring the square root of 5 is 5. So a is 1. And now we can evaluate that tan x equals opposite over adjacent, which is 1/2. Okay. Given that y equals arc sine x, find cosine y. All right. So here we go. Ready, guys? Let's do our arc sine, right? So we're on sine, so we're going to be over here. Let's do sine is, so it needs to be above, right? So we're going to, now of x, right? Sine is opposite over hypotenuse. But guys, what do you notice? X as a fraction is x over 1. So when we talk about this, the opposite is x, the hypotenuse is 1. So even though it's just x, remember it's x over 1. Now we can do our Pythagorean theorem, right? So let's do this. Let's go a squared plus x squared equals 1 squared, which is 1. Move that over, take the square root. So that means this side is the square root of 1 minus x squared. So now if we did cosine y, well, cosine is what over what? Cosine is adjacent over hypotenuse. Okay, I know that's where a lot of people in my class last year struggled because they wanted numbers and not variables. But that is actually helping us get to the derivative, because we're going to use our work from example 8 to find the derivative of arc cosine. Okay, so remember, we said in number 8 that y equals arc sine of x, right? So let's make this a little bit easier on ourselves. Let's get rid of the arc sine, because at this moment we do not know what the derivative is. So to get rid of the arc sine, we'd have to take the sine of both sides. So there we go. Now let's do our derivative, but don't forget this is implicit now. So the derivative of sine is cosine y. But we also have to multiply it or hook on that y prime equals 1. Now, if we solve for the derivative, because that was the whole point, right, was the derivative, we would get y prime equals 1 over cosine y. Now, didn't we just solve for cosine y above here? We did. So y prime equals 1 over, now do we need that really to be over 1? No, we don't. And that is where we get the derivative of arc sine. Do you have to remember how to prove it? No. What you do have to do is know how to use it. Now, if you've already done your derivative packet, which you should have, you would know how to do this. So make sure you are using your rules and that you multiply by the derivative of the inside, okay? So g prime of y equals, well, the derivative of tangent is 1 over 1 plus the inside squared, and then don't forget we also have to multiply that by the derivative of the inside. Derivative of the inside is 2. Okay, 11, this is arc sine, right? So f prime of x equals, I'm going to do it this way, the derivative of sine or arc sine is 1 over the square root of 1 minus that inside squared times the derivative of that inside. The derivative of that inside, which you could do on the side, is 1/2 x to the negative 1/2. Okay. Now, could we simplify this more? Yes, we could bring this square root down. We can bring that 1/2 in front. We can also make this 1 minus x, right? Because the square root squared is just x. So depending on how you want your answers. Let me give myself a little bit more room here. So the derivative of inverse cosine equals, so let me do that cosine first. So -1 all over square root of 1 minus ln of t squared, that inside squared, times, and then the derivative of the inside, which is 1 over t. There we go. Did it. All done, guys. Try that out. If you have any questions, ask.